Hi guys, myself Pranab is here to deliver today's presentation, Power Transformer Part 54. As the subject is of the continuation, so for your convenience, the link of the previous one is given under the description box. Let's start with phase sequence and relative phase displacement criteria for transformers connected in parallel operation. In case of three-phase or polyphase transformers, while going to connect in parallel on both LV side and HV side, then to have a satisfactory performance, it is necessary to maintain the underneath features of the connecting transformers. One, same polarity. Number two, same phase sequence. Number three, zero relative phase displacement angle. Number four, almost identical voltage ratio. And number five, moderate or limited disparity in per unit impedance. First three are essential mandatory features. That is same polarity, same phase sequence, zero relative phase displacement angle. These three are the essential mandatory features. If there is any disparity in polarity of the connecting transformers, then a dead short circuit would have been the resultant effect. For additional load requirements, two or more three-phase transformers can be connected in parallel, subject to have their phase angular displacements, that is, phase rotation between high and low voltages must be the identical. Now, underneath combinations are admissible for parallel connections. Transformer 1 and 2, transformer 1 star star, transformer 2 delta delta. It is admissible to connect in parallel. Star delta, delta star, delta delta, delta delta, star star, star star, star delta, star Z, that is zigzag transformer. Underneath vector groups are admissible for parallel connections. Group 1, vector group star star 0, delta delta 0, delta Z 0. Phase displacement of the secondary with respect to the primary, zero relative phase displacement angle, and admissible for parallel connection only within the group itself, that is group 1. Group 2, star star 6, delta delta 6, delta Z 6, that is 180-degree relative phase displacement angle and admissible for parallel connection only within the group 2. Number 3, star delta 1, delta star 1, star Z, that is zigzag 1. Phase displacement of the secondary with respect to the primary, that is minus 30-degree relative phase displacement angle. Number 4, star delta 1 1, delta star 1 1, star zigzag 1 1. Phase displacement plus 30-degree relative phase displacement angle. These group 3 and 4 can be connected in parallel with each other. The group of transformers, while operating in parallel, there might have been possible to some extent of adjustments at their turns ratios so as to make their voltage ratios more or less same, but any sort of phase divergence that can never be counterpoised if there may have a different phase sequence of line voltages of both the transformers, then in every cycle, each pair of phases will get short circuited and a flow of circulating current in the network. So, it is worth to note that in case of polyphase transformers, which corresponds to the same vector group or phase angle shift alone must be taken into consideration for the paralleling operation. However, transformer of having minus 30-degree angle can be paralleled to a transformer of having plus 30-degree angle by reversing the phase sequence of both primary and secondary terminals of one of the transformers. Supportive guidelines on paralleling transformers performance parameters. Specific situation of utilizing transformers operating in parallel that may have to arise when the supplied power would have become greater than the capacity of an existing transformer. This is be the most preferred practice as because there would have some technical advantages to run another transformer in parallel with the existing or old transformer. However, it is rather difficult to manufacture two extremely identical rated transformers with the same value of impedance on their own MVA base ratings. The International Electrotechnical Commission IEC 60076 has made a comprehensive standard that provides guidelines for the design, manufacturing, testing, and commissioning of power transformers for both indoor and outdoor use. The IEC 60076 standard has achieved an worldwide recognition, and its recent revision was published in 2020. Different aspects of transformer design are being clearly indicated in the standard, which includes the electrical, mechanical, and thermal aspects. It provides specifications for transformers of different voltage levels and power ratings, and also helps to contribute important guidelines regarding selection of materials, insulation, and constructional methods. Comprehensive maintenance and testing procedural directives has also been framed in this standard for safe and reliable operation of power transformers. The standards to cover all power transformers up to a voltage rating of 765 kV and also specifies the single phase and three phase transformers, auto transformers, and reactors. While new transformers would have to connect for paralleling operation with existing transformers, then underneath criteria of the existing transformers that should have to be taken care of. One, rated power. Number two, rated voltage and rated voltage ratio. Number three, voltage ratios corresponding to tappings other than the principal tapping. Number four, load loss at rated current on the principal tapping, corrected to the appropriate reference temperature. Number 5, short circuit impedance on the principal tapping and at least on the extreme tappings if the tapping range of the tapped winding exceeds plus minus 5%. Diagram of connections or connection symbol or both. Number 7, the transformer must be capable of being overloaded in accordance with IEC 600767. Now, standard IEC 600762 specifies the maximum allowable limit of temperature rise for transformer operating at normal conditions. Most important. It also recommends to determine the adjustable factors as regards to maintain the allowable tolerance level beyond this point. Maximum temperature rise in degrees Celsius is actually based on the design class of insulation as meant for transformer winding. In accordance with the IEC 600762 standard, the temperature rise type test would have to be performed so as to determine the acceptable temperature rise of the transformer winding and its composite insulation system, including the oil used as coolant. The temperature rise type test that must be essential to conduct under normal operating conditions, including the rated voltage, frequency, and ambient temperature. However, satisfactory results would have to ensure that the subject transformer can operate safely and reliably under normal operating conditions. Importance to verify transformer's nameplate before installation. Transformer while working in the system would simply have to transmit the electrical energy from its primary side to the secondary side through the conversion of electromagnetic energy. It's a basic technical features. Under the specified operating environment and operating conditions, transformers are thus to be characterized and designed accordingly. And that has resulted significant variation in between transformers in terms of size, shape, and specification. The importance of transformer rating as it indicates the maximum power that has to handle by the use of transformer without exceeding its temperature and insulation limits. The actual load capacity of the transformer must have to depend on the voltage levels, power factor, and efficiency of the connected electrical system that would have to be served. All sorts of essential information regarding the technical capabilities and operational parameters of a transformer that would have to be distinctly implied through an indelibly marked rating plate of weatherproof material fitted in a visible position. Nameplate of transformers above 5 MVA that contains the data as specified in the appropriate clause of IS 2026. 1. Type of transformer, that is transformer or auto transformer, Number two, national or internationally recognized standards. Number three, details of the manufacturing company. Number four, manufacturer's serial number. Number five, year of manufacture. Six, cooling class for multiple ratings, ON, AN, or ONAF, OFAF, or ODAF. Number of phases, rated frequency in hertz, rated power in kVA, rated voltages, tap voltages, rated temperature rise in degree centigrade, polarity in case of single phase transformer, phasor or vector diagram in case of polyphase transformer, percent impedance, basic lightning impulse insulation levels BIL of windings at each of the terminals and each bushing separately. Number 17, oil quality, which shall conform as per IS 335/2018 with latest amendment. Number 18, oil capacity. 19, tank to withstand negative pressure for vacuum oil filling purpose. 20, tank to withstand positive pressure. 21, nitrogen pressure if used for tank sealing. 22, weight of the transformer. Detailed diagrams and tables are also to be depicted in the rating plate, which would have to contain A, diagrams of the internal winding connections, B, the voltage vector relationship of the several windings in accordance with IS 2026, C, an accomplished view of the transformer giving the correct physical relationship of the terminals, D, a set of tables that specifies the voltage ratings, ampere ratings, and the connections for all the available taps. Both the plates are to be fixed to the transformer tank at an average height of about 1750 millimeter above the ground level. Criticality in paralleling power transformers of different connecting groups. Underneath consequences that can occur when two transformers of different connecting groups are made to operate in parallel, that is, either be delta or star configuration. Number one, transformers of different connecting groups must have different voltage ratios, which can cause an uneven distribution of current, that is, an unequal distribution of load. Number two, the connecting group that refers to the way the winding of the transformer is connected to the system, and transformers of different connecting groups would have to instigate the production of circulating currents between the transformers. Circulating currents then have to impose additional losses in the equipment itself, causing overheating, which ultimately force to have a potential damage to the insulation system. The circulating currents, once developed, can also lead to a degraded power factor, making the system inefficient. Number 5, paralleling transformers of different connecting groups may have to provoke certain harmonic distortions in the system which create nonlinear distortions of voltage and current waveforms, causing poor quality issues. To avoid all these consequences, it is essential to ensure that the underneath conditions which are to be fulfilled during connection of transformers in parallel. A. Rated voltages, both primary and secondary of all the transformers connected in parallel should be the same, or that must be within an error of 0.5%. B. Transformers should have the same group of connections. C. Short circuit voltages of the transformers should not differ by more than 10%. D. The operational power ratio should not be bigger than one-third of any of the transformers. As of the technical susceptibility and perspectives, the transformers of different connecting groups operating in parallel can lead to several negative consequences that may affect the reliability and efficiency of the power system. To ensure proper system performance and prolonged equipment life, it is perhaps be careful during the selection of transformers which are being proposed to connect in parallel. Most preferable parallel operation of transformers that would have been ideally entertained when no transformer secondary current flows in the no load state. Transformers are being loaded proportionally to their rated power, and the respective currents of individual transformers would be in phase with each other. It is rather recommended that transformers of different current connecting groups, while forced to operate in parallel, then additional measures must be implemented to balance the load to share between the transformers, and simultaneously subsequent steps should have to be taken for restricting the effects of circulating currents and harmonic distortions. Most important. Let's stop here. Further to be continued at later stage. Thank you. Thank you for listening the video. Kindly do like, share and subscribe. Your subscription would encourage to post more videos. Also share your comments or feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section, please. Thank you. Thank you for patient hearing.